I'm Peat Wasilewski from the Goddard Space Flight Center, Laboratory for Extraterrestrial Physics, Astrochemistry Branch.
And I'm Valerie Thomas. I'm with the MUSPIN project. MUSPIN is the Minority University Space Interdisciplinary Network.
And the reason why we're here is to basically introduce you to a very unique project. It's a expedition right to the edge of the Bolivian Amazon to essentially verify that a circular feature that you can see right here on this Landsat picture might be indeed a meteor impact or cometary impact crater. In 1985, when this picture was taken, some people looked at that circular feature, and it was clear that within 500 kilometers there was no volcano, there was no karst topography indicating collapsed structures of any kind, there was no salt dome. So the supposition was, a meteorite impact crater. In 1989, people tried to reach it and couldn't. This was sponsored by the National Geographic Society. And in 1998, I was part of an expedition that actually flew from River Alta, which is at about 150 miles away from here, by Cessna, to a landing strip, which is about here, and we went down the river and essentially cut a pathway through the jungle right to the edge, and then we ran out of time. It was a very arduous task. It took roughly a week just to cut a trail through the jungle. And so we have a broad spectrum of collaborators and interests. We have education, we have science, and Valerie, who works for MUSPIN, plays a very important role in this entire effort.
MUSPIN is very interested in this project because MUSPIN's constituents are African Americans, Native Americans, and Hispanics, and we want to prepare them and give them experiences working with NASA-related activities, especially authentic scientific activities. Right now we're focusing on getting the students involved in mission-oriented projects. This particular activity is very good because it's feet wet and something similar to a real NASA scientific project. And we will have MUSPIN teachers participating on all of the teams.
One unique part of this whole entire expedition is we'll have what's called a UAV. It's an unmanned aero vehicle. It's kind of a sophisticated model airplane. It's got a 12-foot wingspan, weighs about 40 pounds, has an engine, a gasoline engine of about 2 horsepower, and on board will be a GPS receiver, an automatic pilot system, a computer, and magnetometers made by Mario Acuna, who has sent these kinds of magnetometers, in fact almost identical ones, to every planet in the solar system to measure the magnetic field of those planets. So this is the first for him. So you have a unique combination of technical and scientific expertise being brought together in this expedition. And importantly, you have teacher scientists, basically, at both the high school and junior high school level, being part of 4 teams. There's a magnetometer team, there's a landscape reconstruction team, there's the crater science education team, and then there's the magplane team, which is really a technology team. And the technology team will be mostly structured by people from the MUSPIN program.
And this is going to be a very good opportunity for MUSPIN schools because since the magplane technology group is here at Goddard, and we're going to use MUSPIN teachers who are in the area, they will have an opportunity to come and visit the lab, see it being built, hear from the experts who are working on it, and also may even have an opportunity to go and watch And I've already talked to some potential teachers. I've had word that got to some potential teachers, and they're very excited about the opportunity and also the applications that they can use once they get it back into the classroom. So we're really very excited. And I should also mention too, one of the other teams, the landscape reconstruction team, we have a person, a Newsman person, who will be part of the expedition team. And he's from New York, and he'll be going down to Bolivia and collecting data for a pollen study.
And the unique aspect of this is that there will be 2 Bolivian students, early high school. So we'll actually have what every teacher and what every student would really like. 1 teacher and 1 student, one-on-one. How about that, teachers? And there'll be actually 2 teachers, 2 bona fide teachers from high school, and there will be 2 students that are in early high school, and they will actually interact, doing particular kinds of things that we hope to build essentially and eventually into a resource that can be trainers for the teachers.
Another aspect of the project is, as the scientists are collecting data in the field, they'll be putting it onto the internet. So the teachers who are here on the various teams will be able to, access the data and do analysis and be part of the team. Also, we'll be bringing the team together for a week during the summer, so they have a chance to interact with the scientists who will be on these teams too. So it's going to be a very interesting opportunity for everybody. I think the scientists will probably get as much of, as much excitement out of it as the teachers. What do you think?
Yeah, I think so. I mean, there's going to be something for everybody. Tim Killeen received a biodiversity prize for his work in the Bolivian rainforest and essentially all the ecosystems in Bolivia. And he'll be teamed up with Compton Tucker from Goddard here, and there'll be students. There'll be students who study bugs, and study birds, and study reptiles, and they'll all be working together on this kind of thing. And all this information, almost in real time, or near real time, will be coming back by actually 3 different satellite systems. There'll be Inmarsat that will come from the Magplane site. There'll be an Iridium telephone or Globalstar that will be transmitting from the airplane, and then probably either Iridium or Inmarsat we'll have at the crater. So all this information, audio, digital images, and data will be coming back, and the teacher teams will be able to interact with us. And for example, the Magplane team will see their baby fly, okay? And before the airplane actually goes down, they'll be participating in a flight test and kind of an engine test, the avionics test. So it'll be a kind of really unique experience for them.
And also, people who are familiar with GLOBE will also be using some of the GLOBE protocols for the landscape reconstruction team.
Right. Elisa Levine from here at Goddard is the primary soil scientist for GLOBE, and she is essentially the head of the landscape reconstruction effort. And so when the Magplane team goes down the Rio Manupare to collect soil samples, they will be every GLOBE person that's ever done a soil sampling will see, wow, I did that. But this will be done for a real scientific purpose, to reconstruct the landscape. It's never been done before.